Now we are seeing the first chapter, rotational dynamics. This is the video number 3, and in that session we have to see the new point, the conical pendulum. You have to ask the question in your board pattern, define the conical pendulum and derive the expression for the period of conical pendulum. And for that purpose you have to draw the first diagram, consider part, then definition of conical pendulum and mathematical steps. Now we draw the first diagram, this conical pendulum. We are familiar with the simple pendulum, so that we can define the simple pendulum and which convert into the conical pendulum. What is meant by the simple pendulum? A heavy mass sphere suspended by weightless inextensible string which fixed to the rigid support is called as the simple pendulum. This is the pendulum, this is the heavy mass sphere which can be suspended by weightless inextensible string fixed to the rigid support is called as the simple pendulum. Suppose that pendulum which can be displaced in such a way that which can be the revolves in a circular path with the constant speed then and then, which is called as the conical pendulum. If that simple pendulum which can be displaced along the horizontal circular path with the constant speed then and then, this is called as a conical pendulum. We have drawn here the conical pendulum, in that this is the fixed rigid support at point O, this is the point of suspension, then which can be the revolves in circular path along with the horizontal circular path with the constant speed. Then it displaces from point A to the B having the radius, then tension, then the length of the string and this height, and making an angle of inclination along with this rigid support. If you have to understand this diagram, then you can just write the consider part in simple way. Let m is the mass of this pendulum, r is the radius of that circular path, horizontal circular path, l is the length of the pendulum, then t is the tension in the string, and this angle theta is the inclination along with the fixed rigid support. When this pendulum which can be displaced in a horizontal circular path, that means in conical pendulum displacement motion, at that time there are the two types of the forces acting on that bob. This pendulum is, in short, we can say the bob, and in displaced position the two types of the forces which are act on this bob, and these forces are nothing but, first force is the weight mg act vertically downward direction, and second force is the tension in the string which is as shown in figure. There are the two types of the forces act on this bob in the displaced position along with the horizontal curve path. At that time there are these two types of the forces. First is what? The weight mg act in vertically downward direction, and second one is the tension which is in the string. But what happened? This tension in the string which can be resolved into the two components. This tension which can be resolved into two components. First component is vertical component T cos theta, which is as shown in figure also. T cos theta, this is the vertical component, and horizontal component T sin theta, which is also as shown in figure. These two arrow, vertical component T cos theta, horizontal component T sin theta, both are as shown in figure. But what happened? This vertical component T cos theta, which can be balanced by the weight mg, which can be the balanced by the weight mg, which is vertically downward direction. So that we can write here T cos theta is equal to mg. This is the equation number 1. Then also the horizontal component, you can see here this horizontal component T sin theta, which can be directed towards the center of this circular path. Horizontal component T sin theta, which can be directed towards the center of the circular path, so that it is acts as a centripetal force, and so that we can write here T sin theta is equal to mv square upon r, and this is the equation number 2. Then we can taking the ratio of equation 2 and 1, because sin theta is for equation 2, therefore we take the ratio for the equation 2 and 1. then what will happen? The t sin theta upon t cos theta is equal to mv square upon r upon mg, this upon this mv square upon r upon mg. Then what will happen? The t get cancelled, sin upon cos, you know that this is the tan theta, then also get cancelled, then remaining terms are only v square upon rg. Therefore, tan theta is equal to v square upon rg. This is the equation number 1. Or also we can write here v square is equal to rg tan theta, or v is equal to under root rg tan theta. This is also a maximum speed with which this pendulum can be displaced along with the horizontal circular path. V is equal to under root rg tan theta. This is the equation number 4. Now we can find out the period of conical pendulum, and for that purpose we can take the trigonometric ratio from this figure. You can learn in 10 standard, 11 standards in mathematics. From figure we can see here that we have to find out this trigonometric relation for tan theta. You know that sine opposite upon hypo, cos adjacent upon hypo, and same way tan theta opposite upon adjacent. For angle this theta, this is the tan theta. Tan theta is nothing but what? Opposite, this is nothing but the AC, and adjacent, it is nothing but the OC. Therefore, tan theta is equal to AC upon OC, we can write here. But OC is nothing but the radius, and this OC is nothing but the height. Therefore, we can write here tan theta is equal to AC upon OC is equal to R upon H. From this equation 3, tan theta is equal to v square upon rg. We can write here v square upon rg is equal to r upon h. Therefore, r take this side, right hand side, this r is taken here the denominator side. Therefore, v square upon r square is equal to g upon h, taking the square root, the v upon r is equal to under root g upon h, and this is the equation number 5. You just see trigonometric relation and rearrangement in the mathematical steps, then you can directly write v upon r is equal to under root g upon h, equation number 5. Then we know that the formula for the period of pendulum, this is nothing but the t is equal to 2 pi r upon v. Sometime you have to probably how this formula has come, then you know that the v speed is nothing but what? Distance upon time. Time take this side, this is the period, and this 2 pi r is nothing but that circumference. This is the distance 2 pi r, because this is the circular path, and therefore 2 pi r upon v, this is the speed, t is equal to 2 pi r upon v. But we have to find here the v upon r, then take this r upon v is equal to, instead of g upon h, this is nothing but the h upon g, and this substituting r upon v, we have to substitute here the root h upon g. Therefore, t is equal to 2 pi under root h upon g. This is the equation number 6. This is the one type of this period of pendulum, t is equal to 2 pi under root h upon g. Then also from figure we can write for the trigonometric relation for the cos theta, and this cos theta is nothing but what? This is the adjacent upon the hypo, and therefore hypo is L and this adjacent side is the L H. Therefore, we can write here cos theta, adjacent side is H, and hypo, opposite sides of the 90 degrees, this is nothing but the hypo. Therefore, H upon L, this is nothing but the cos theta. Therefore, we can write here the cos theta is equal to H upon L, and therefore H is equal to, take L this side, then H is equal to L cos theta, and substituting this value in above equation number 6, H, value of the H is L cos theta. Substituting this, then we can write here t is equal to 2 pi under root, instead of H we can write here L cos theta, t is equal to 2 pi under root L cos theta upon g, and this is the equation number 7. This is nothing but this equation is represent the period of conical pendulum. Very simple, you can also solve this numerical on this formula, t is equal to 2 pi under root L cos theta upon g. Also sometime you have to ask on which factor this conical pendulum, period of conical pendulum depends on. Then we can write the period of conical pendulum is depends upon the length of this pendulum, the angle of inclination along with the fixed rigid support, then acceleration due to the gravity on this factor the period of conical pendulum depends on. So, this is the very important point for 3 marks. The marking scheme is half marks for the this your diagram with consider part, half marks for the definition of this conical pendulum. Then mathematical steps you have to this equation number 1, 2, 3, 4, this is for the 1 marks, and up to number equation 6 you have to got also 1 marks, and remaining you have to, instead of definition there are asked on which factor this conical period of the conical pendulum depends. Next lecture we have to see the different positions of the energy and velocity in between them. But further you have to one assignment to find out the tension of the conical pendulum. I can say you how you can find out this tension in the string. You can try this. Half part is also same, the t cos theta is equal to mg t sin theta is equal to mv square upon r. Then you can just the squaring and adding the LHS and RHS, and for mathematical steps you can solve this. We can find out the tension of the conical pendulum, and the formula for this tension of this conical pendulum is nothing but what, T is equal to mg into bracket 1 plus r upon h square. This is the tension. This is also very simple. You can find out also by using this equation number 1, squaring and adding on the LHS and the RHS, and solving with the help of this mathematical steps. You can got this final equation of the tension in the conical pendulum, T is equal to mg in square root 1 plus r upon h square. Okay. So, this is the video number 3 for the conical pendulum and the tension of the conical pendulum. You can just write 2 or 3 times practice, because you know that the practice makes man perfect. 12th standard science is very hard. Just you have to practice, then you can got easy and you write well. Okay. Thank you.